Okay, so I've not designed the workshop. So if you know someone called Les Pounder, you probably do know him. He is a writer as a day job, and he has written an EduBlocks curriculum which will be being released next week. And the idea of this is just to give people an introduction as to what EduBlocks is and hopefully give you something to do. So it's designed as a workshop, so the idea is that you can join in. So what you'll want to do is you will want to go to edublocks.org. So if I put the link in the chat, it's probably best. So if you go to that link there, which is edublocks.org, you will see this website here with like the bluey purple background. And the idea of EduBlocks is it's a tool to help people who want to move from blocks, so mainly Scratch or MakeCode, into a text-based programming language like Python. And EduBlocks has been around for about 3 years. No, not 3 years, about 4 years. And recently, in the past year, I had developed it so that people can use it on any device. So it used to just be for the Raspberry Pi, but now you can use it on any device, and hopefully you can join in on whatever device you're using today. So once you get to this screen, if you press the Start Creating button, you will get to a screen that looks like this. So EduBlocks has a few different modes. The one we'll be using is Python 3. So if you wanted to go away from this workshop and use something like the Raspberry Pi Microbit or a CircuitPython device by Adafruit, you can also do that. So once you get to this screen, you can press select and you get a editor that looks like this with your block toolbar on the left, a file name at the top, and then some buttons at the top here to save and run your code. So if I go into the presentation, so what we will be doing today is using a library in Python called Turtle. And what Turtle is it's simply a way to draw with Python. And the reason I really like Turtle is it provides a really good visual way to learn with Python. Now, Python, for some people who have come from scratch, can be quite boring because they're faced with just a text-based programming language rather than a cat with a stage where you can draw stuff and make games. But what Turtle does is it allows you to have this kind of Scratch-like interface that you are used to, but in a Python environment. So Turtle, just as a bit of an origin, was created as part of Lowe, which was created in 1967. And basically what it was is it was a robot that would draw patterns on paper. And what Turtle is, it's a Python way of emulating what that robot would do on the paper, but on the screen. And it's really simple to use. So with Turtle, we can create a sequence of code in Python and see an image, and we can use different loops to make patterns. So there are a few coding concepts there that I've just mentioned. So we've done that. You should get to the Python editor here. Okay, so let's start by creating some code. So the first block of code that we need is in this Turtle menu here. So it's Turtle import. So we need to import the Turtle library so that we have something to work with, so we can reference all of these functions within Turtle. The next one is we need to initialize Turtle. So we need to initialize the actual Turtle drawing pen, if you will. And then the next one is initialize the Turtle screen. So Turtle has a canvas, so like a canvas in art, and that initializes that canvas of which we can draw on. So once we've got all that sorted, they are our initial initialization blocks. So let's try and draw a square. So very simply, let's try and draw a square. So the code that we want to add is a forward 90. So if we do forward and then 90, and then the next one is left 90. So you can just right click on that one, duplicate it, drag it underneath, and then change forward to left. And then we want another forward 90. And then another left 90. Okay, so that's what that piece of code does. Now, if I just leave that up for 20 seconds so that you can copy that. Then if I try and run it, so it's forward, left, we can see that that draws the first part of the square. So how can we adapt that to further create a square? So let's see if you can take this code here and then turn it into a square. So can anyone suggest in the chat what we might add to this code to complete the square? So just wait for some replies. So Simon's suggesting if we could do it with a loop. Repeat with a loop. So there are a few ways that we could do it. So we could basically add 2 of these, and then another 2, like that, and press run, and that would complete the square. But you can see that there's quite a lot of blocks here, and that's not really necessary. So what we can do is we can use something called a loop. So that's the next slide. So you can see that we can cut this code down into just a few blocks using something called iteration. And basically, if you look here, you can see that these 2 blocks are just repeated 4 times, and that's not really necessary. So what we could do is if we remove these blocks here, so we're just left with these 2, go into loops and then get this 4 iron range number, and then put that around those 2 blocks, change that to 4, and if we run it, you can see that it'll do exactly the same thing. So that's using a loop to cut down our code. Now, if you're using something called something like the microbit, which only has a very limited amount of space, using loops can be quite good because you can actually fit in more code. Because the microbit only has a limited amount of space, you can fit in more code to do more things by using loops and little tricks like this to fit it on that small space. So we can use this loop to do that. Now, how do we draw a different shape? So let's try and draw a triangle. So draw a triangle. What we can do is we can change this loop to 3, forward 100, and then here, what do we think we should put there? So can anyone suggest what we can do to put there to make a triangle? I think it's already showed up on the screen. So Gary and Tracy has suggested 120. So should we try that? Are we continuing with left? Yeah, there we go. That creates our triangle. So Simon said 60, so I wonder what 60 is. That creates another shape there, so half a hexagon. So that is how we can use loops. So this is kind of a way to remember it. So the turning angle, we can do that by dividing 360 by the number of sides the shape has. So that's quite a handy thing to know. Now, how can we make something a little bit more interesting? So you can see that we've got squares and triangles, but that can be quite boring. So let's try and draw a pattern. So if we go back to our editor here, and then remove that bit of code there. So to create a pattern, what we can do is if we get a while true, so that's similar to a forever loop in Scratch, I think is what it's called. And then if we get another for I in range loop, and then if we change that to 3, and then go into turtle, get a forward block, change that to 50, get a left, I keep clicking on the wrong thing, change that to 120, and then add right at the bottom there. And then change that to 10. And if we run that, see that we start to get a pattern. So you can see how we can quickly change our code to do more interesting things than just drawing squares and triangles. So that is simple to do. So each time the loop iterates, we move the turtle by 10 pixels, which instead of just drawing the triangle over each other, it will create this pattern effect like that. Now you can see that we've got a pattern and we have just a black pen color. How can we change that pen color? So that's quite easy to do. So there are a few things that we can do to change our code here. So in Turtle, there are a few blocks that we can use to change things up a bit. So we can change the speed. So we can change that to speed 100, or you can change that to speed 0 if you want it to be really quick. We can change the pen color like this to red, and we can change the width to, let's say, 20. So there are a few things that we can change the color to. So if I just highlight this here, so in Turtle we use what are called RGB values, so red, green, and blue. So each value has 3 numbers, and they go from 0 to 255, and you can change those to create different colors. So some examples are, if you want to create red, then you put 255 in the first number. If you want green, then you put it in the second number, and then 255 in the last number to make blue. And you can mix those up, so you could do 255 on the first number, then 0, and then 255 on blue to make purple. So if we try and run that code now, we can see that that makes a pattern like that, and because the width is 20, it kind of covers up all of those gaps. So let's try changing that to 10. We see that we have a little bit more of a gap there, and if we change it to maybe 5, see, that's a bit more, that's a bit better. So here is a challenge. How can we get it so that it changes the pen color on each triangle? Can anyone suggest what we might do there? I'll just wait for someone to say what we could do in the chat. So if we wanted to change the pen color on each individual triangle. So Scott has suggested add variables for RGB and add a value to those values on each run around the loop. Yes, that's one way we could do it. So if I open up a sample here, oh, that's a good suggestion. So a random command. So actually, before I go into the next bit, if we create a list of some colors, now the good thing about turtle is that just rename that to colors, is that you don't actually have to suggest RGB values. What you could do is you can just put quotes red, yellow, and it's got pre-programmed colors, so green, blue. Obviously you can't put colors that no one's ever heard of in there, else it won't know what to do. So if we do turtle.penColor, change this a bit so that we have colors there, pen color, and then get random choice, and then colors, change the widths, then duplicate that there again, like that. So hopefully that should then, oh, random is not defined. That's a mistake that I forgot. So we import random. And we can see that that now changes the color each time that we have a new triangle. So that is a quick example of how we can change a bit. One of the other things that we can change is the background color if we want to. So for example, if we do a black background, you see that you can change that like that. So that is, oh, I don't want to do that. Right, so that is a quick example of how we can change a few things there. So now that we have learned how to create a pattern, I'm going to set everyone a quick challenge. So if I leave this up here so that people can copy the code, what I want you to do is see what you can change, see what you can add with the turtle library, with what I've already got as some code here, and try and make your own pattern. So if I leave this code up here so that people can copy that down and change it, if I give people about 7 minutes till about past and see what they can create, I think that would be a good idea. So Simon says, how do we copy it? So you should be able to see the code on the screen. Does that not show up?
We can see the code on the screen. I mean, there are a couple of people are saying at the moment, oh, slow down. And just bear in mind that all of this is recorded. So within an hour or two of the event finishing, we'll automatically have a recording on there that you can go back. I mean, Josh, it might be worth, when you're doing some of the bits, to try to zoom in just on certain blocks.
Okay.
But I realized sometimes it's nice to be able to see all of it at the same time.
Okay. So would it be a good idea just for me to explain what everything does first before people try and make their own thing? So if I just zoom in here, so I went through the imports at the top. So this imports random and turtle. The third one initializes turtle, so the actual pen, and then the fourth one initializes canvas. This block here changes the speed, so 0 is the fastest speed, even though that probably doesn't make sense. Colors is just a list, so I've just put some quotation marks here and then put a comma and then another color, and you can choose some very basic colors to put there. This just changes the pen color, and what this block here does is it chooses a random color from this list, so you can see that those two match up there. This changes the canvas color, so the background color. So I just selected black there, but you can change that to an RGB value if you wanted. So if I run that, I'll go back to it in a minute. See that changes it to purple. So that changes the background color. That changes how that changes the width of the pen. This is a forever loop, so anything inside of this loop that is highlighted in not yellow will run all of the time. This block here, so the 2 blocks inside of this for loop, will run 3 times, and it will go forward, and then it will turn left by 120 degrees, because that's how we make a triangle. What you could do here, if you change that, that'll make a square, so you can do a different pattern like that. So what you do, if you want a different shape, you find out how many sides it has, and then divide that by 4. Right will move the pen by 10. So that's how we create a pattern instead of it just going over each other. So you can see that changing it to 20 does something a little bit different. And then this just changes the pen color when we go around the loop again. So if I lead that up, hopefully people can see it. If you can't see it, what I'll do is I'll save the file and I'll put it in a Google Drive link for you to download. And yeah, so I'll put it in a Google Drive link for you to download, and then you can just press open there if you can't see the screen very well, if you want to change things up a bit. So I'll put that in the chat now, but I'll leave that up if you want to create your own pattern for the next 5 minutes, and we'll see what people can create. And if you've got one that you want to show, you can quickly post it on Twitter or something, or you can quickly share your screen after the 5 minutes is over. I'll just let people have a go with that now. So I've put the Google Drive link to the file that I've got up here if you want to download and open that. So it's just an XML file. So when you click on that, you should see a little download icon, and you can download and open that. So Andrew's posted an error. One of the things that I might suggest with that, I can't remember, but I have seen something similar to that before. It might be that if you're choosing, if you're indexing a loop via the, I'm just trying to figure out the best way to explain it. So that, say you've got 5 items in the list, and you're referencing that list somewhere else, and it's like a for loop, and it's trying to find a 6th item, it might throw that error, but I'm not sure. Like Martin said, we'd have to see the code for us to kind of figure it out.
We should have some background music playing so people know that we're still broadcasting. So Josh has set a problem for people to try to solve.
So just if I just show Andrew very quickly, so you see this blocks button here under run. If you click that, then you get the Python view, and if you just copy and paste that, I can have a look at it. So for some reason, on Andrew's code, it looks like there's no equal sign in between colors and the square bracket for the list. I think that's probably what that is. So I don't know how you've got to that. So if you look on mine, in between colors and red, there's an equal sign. So that might be an issue. So Simon says he's changed the width randomly. Does Simon want to share his screen so that people can see what he's done?
We're just waiting to see if Simon can do a screen share so we can have a look at what Simon's been working on.
I think he's gone off.
Okay.
Maybe it's not working for him or something.
Are you okay for another minute or two? Maybe because I'm supposed to start at 3:40 with this scratch.
Yeah.
Oh, who's this doing? Oh, it was you. Okay.
See, oh, Simon's come back now. Does Simon want to take it over again?
Okay.
It's all right. I think Simon's posted his to Twitter. I think I got a notification for something. Could probably show it that way. Does anyone else have something that they want to show before we move on? So whilst people are talking in the chat, one thing that would be worth pointing out is if you want something similar to Turtle that's a bit more advanced, if I just duplicate this so that I don't get rid of that code, then you can go into samples and then click on processing. And processing is a bit more advanced, but it's a bit different. You can see this is like a similar thing to Scratch where you get the cat to follow the mouse. So it's a similar example to that. So Python can emulate things like Scratch, but it's just a bit of a different language to learn. But you can see that something similar does exist. So if I bring up the presentation again, which I have now lost, I think. So if you wanted an example pattern, that would be something similar there. And what that draws is, it draws something like this. So very similar to what I did, but just with a few more bits and pieces in there. There's other things that you can draw as well with Turtle, like a circle, which is turtle.circle. So you can see here that it's just a turtle pattern to draw a similar pattern but with a different shape. So there's all sorts of different shapes that you can draw as well in there. Oh, Simon's posted his thing here, if I can bring that up. So you can see that the width has randomly changed, so it's not just all the same, and the background's changed as well. So that's cool. So just to recap what we've learned how to use sequences to control Turtle, learn how to use the different loops, so like a while true loop and a for loop, and also some maths as well to create the different shapes. So that is it for me. I hope you enjoyed it and learned something. These workshops, lessons will be on the EduBlocks website next week if you want to access them afterwards. But I hope you found it useful. So I think it's over to Alan now.